Hello, I am Harshvardhan from third year BTech Engineering Physics at IIT Roorkee. I will be demonstrating the working of strain gauge. So let's begin. Let us first start with what is strain. Suppose there is a rod of length L and then you pull the rod from both the ends uh, with a force, and the rod extends by a value, say delta. The quantity delta over L, which is the original length, is known as strain. Now let us come to the main topic, which is strain gauge. The image which you are seeing in front is the image of a strain gauge, a diagram of a strain gauge to be precise. Strain gauge is a sensor whose resistance varies with applied force. It converts force, pressure, tension, weight, etc. into a change in electrical resistance, which can then be measured. In this slide, we will try to visually understand how the strain gauge functions. Like this is a piece of log. It was straight earlier. Suppose this is a straight line like this, and then a force is applied here. So the log bends like this, and as you can visualize, the upper part, the wire, this is a strain gauge attached. The strain gauge here will try to extend in these two directions. As a result, the length of the wire in the strain gauge will increase, and as we know, resistance is directly proportional to the length of the wire. As the length increases, the resistance will also increase, and which will result in the creation of the potential difference between the points shown in the circuit in last slide. This is the mathematical understanding of what we have seen earlier. As resistance is directly proportional to length, the change in resistance will also be directly proportional to the change in length. And as we know, delta L by L is known as strain, or delta R by R upon K, where K is the gauge factor which varies with the type of gauges used. The strain will vary. So this is how the experimental apparatus of a strain gauge strainer kit look like. It gets a bit complicated in real life. The black stone-like things which you are seeing at the bottom are the weights which we'll be using for the experiment. The 500 gram weight, the 200 gram weights, and the 100 gram weight. And now let us switch on the apparatus, strain gauge. First, we need to make the reading to zero using the zero adjuster. Uh, Once it goes to zero, we will give it a bit of a gain to increase its sensitivity so that we get different reading on adding weights. So let's first place the 100 gram weight and note the reading. As we can see, it is 0.11. Now we will increase the weight slowly. Place the 200 gram weight on the gauge. We can see the reading has increased to 0.22. Now the total weight is 300 gram and the reading has increased to 0.33. One thing which you can note is that a linear graph is coming with the readings. Like 500 kg weight is there and the resistance has now become around 0.55. And now placing all the weights, making it a total of 1 kg. The resistance is now 1.08. Now placing all the weights, making it a total of 1 kg. The resistance is now 1.08. The following is the data from the experiment performed. I have plotted the graph using Excel with the weights in grams on the x-axis here and the resistance on the y-axis. It is pretty clear from the graph that the points make a straight line, which is a great thing for us as this makes our job easy. And if you can observe, the microstrain values also show a proportionality with the weights. As you would have get to know till now that this is a pretty easy experiment, but this easy experiment has a wide variety of usage and application. I have mentioned three of them here. So let's start with the first one, rail monitoring. It is not just the train that must be checked, but the rail tracks themselves because they are subjected to heavy stress when heavy trains pass over them at high speed. Tracks are also subjected to stress and strain due to shifting of earth below them, potentially caused by tectonic activity, frost heaven, sinkholes, the possible presence of mines below them. So the measurement of strain here plays a very important role. The second application being automotive strain gauge application. As we know, every kind of vehicle undergoes extensive testing during development. This includes cars, trucks, buses, and motorcycles. Body panels are often instrumented with dozens of strain gauges. This allows engineers to see how the panels move when subjected to a variety of road conditions at variety of speeds and on different driving surfaces. Crash test dummies are equipped with strain gauge and other sensors to measure the forces on vehicle occupants during a variety of standardized safety tests. Strain gauges are used in passenger seat to determine whether the seat is occupied or not. This determines whether the airbags at this seat would deploy in the event of an accident or not. They can be used to deploy the airbag at a reduced speed in the event that a child is in the seat as opposed to a heavier adult. And the last but not the least application, the aerospace strain gauge application. Aeroplanes must be as safe as possible. Of course, rigorous testing is required during development and certification. Aircraft are also tested at regular intervals to ensure that they are structurally sound. Every load-bearing structure in an aircraft must be tested for stress and strain, including wings, critical structure like engine mounts, torque and power measurements on rotating spinning components such as fans, turbines, etc. This brings me to the end of the video. Thank you.